Hi, today we're going to be discussing section 3.7, sum and difference of cubes, and a general approach to factoring. In this video, we'll talk about the general approach to factoring and do problem number 9 through problem number 12. Remember, when you're asked to factor completely, that a polynomial is completely factored when it is written as a product of prime polynomials with integer coefficients. Keep factoring the expression until it can't be factored any further. Prime polynomials cannot be further factored. Let's try it. Let's look at number 9. Step 1 to factoring is factor out the greatest common factor. So look at number 9. Is there a GCF that I can factor out? What can I take out of each term? Yes, there is. I can take out a 2 and an x. So I take out that 2x. Essentially, when you take it out, you're dividing each term by 2x. What do I have left when I divide by 2x? I get x squared plus 5x minus 2. Okay, now when I see what's left, I count how many terms. 1, 2, 3. I don't worry about the GCF. He's going to come with me all the way down till the end. I count 3 terms and I know that I have to factor a trinomial. When factoring a trinomial, you have a couple of options. Is a 1. So the coefficient on the x squared term is 1. Awesome. So now we can set up our template. Remember, you're keeping the 2x with you. Now, you set up your template, you split up the x and the x, and you're trying to find two numbers that multiply to give you 2 and add to give you 5. But when I try to multiply, I just get 1 times 2. Notice that no combination of 1 and 2 will ever add to give me 5. So then you know this is completely factored. Problem number 9, completely factored, is 2x times x squared plus 5x minus 2. Sometimes it's completely factored just by factoring out the GCF. Let's look at number 10. Is there something I can factor out? Yes, don't forget, no matter how many terms you have, factor out the GCF. I can take out a 3 and an x, and I'm left with x squared minus 16. Then I count the number of terms, 2. When I have 2 terms, I use a special pattern. So I keep the 3x, and I notice my special pattern here is the difference of squares. So I take the square root to find a and b. And I factor by saying a plus b, a minus b. And I'm completely factored. Let's look at problem 11. What can I take out? I can factor out a 3 from each term. When I factor out a 3, I'm left with 2x squared minus x minus 21. Then I count the number of terms. There are 3 terms, so I know I need to factor the trinomial. My first question is A 1? And A is not 1. When A is not 1, you have several options. We talked about the box method, we talked about the X method, rewriting the middle terms, and we talked about the circle it up method, which is my favorite, so let's do it. The circle it up method is where you multiply A times C. So remember, you multiply by A. 3 is just going to keep coming all the way down, so we'll keep the 3. Here we multiply by a, so we'll have x squared minus x minus 2 times 21, which is 42. Now we can factor just like we did when a is 1. We set up our template, so we know the first piece will be x squared, so x times x. Then we consider the multiples of 42. So you can come over here. 42 is 1 times 42 and 2 times 21 and 3 times 14, 6 times 7. Okay, which one of those will combine to give you 1? Notice the sign is negative. How do you multiply to get a negative? One of each. So I need one positive and one negative. And I need a negative, so the bigger number will be negative. So 6 times 7. As 6 times negative 7 is negative 42. And 6 plus negative 7 is negative 1. So check, I'm good. But don't forget, we're doing the circle it up method. Don't forget to finish your circle. Okay, so we multiplied by A, but we can't just do that willy-nilly. That's not mathematically sound. So now we need to divide by A. So you divide the 7 by 2 and the 6 by 2. Now we see that we have x plus 3 for the first piece. And here 7 and 2 don't simplify and they don't divide, so move that 2 up to be the coefficient to get 2x minus 7. And you are fully factored on problem 11. Great job. We just have one more. Step 1 is to see if there's anything I can take out. Is there a GCF of all the terms? No, there isn't. Step 2 is to count how many terms you have. 1, 2, 3, 4. 4 terms you need to factor by grouping. So you group the first two and you group the second two and you factor by grouping. Now, what can I take out of the first two? It looks like a p. And then I'll have p squared minus 2q squared. Then I factor out a q from the next two terms, and I get p squared minus 2q squared. I have that common binomial that I can now factor out. Notice this is the same, so I can now factor this out. So I take out the p squared minus 2q squared. And what do I have left after I divide each term by that? In the first term, I have p, and the second term, q. Now, am I done? I'm so tempted to think this is the difference of squares. P squared minus q squared. That's p plus q, p minus q. Yes. No. There is a 2 in front of the q squared, and you cannot take the square root without running into decimal issues. So that's it. You are fully factored. I hope you've enjoyed a general review of factoring. Just remember, anytime you're asked to factor a polynomial, step 1 is to factor out the GCF. Step 2 is to count the number of terms. If you have 2 terms, there's a special pattern you need to follow, like the difference of squares or the sum or difference of cubes. If there are 3 terms, then you need to factor the trinomial by using that little template if A is 1, or the circle it up method if A is not 1. If there are 4 terms, you need to factor by grouping. Good luck!